Good morning, everybody. This is our last video lesson. And last time I'm probably going to talk to you guys until Thursday when you come to pick up your things, and Friday when you roll through. And so, I wanted to do something kind of fun. And takes place of your math, takes place of your writing. It's due Thursday. And it's meant to be fun. So I don't want this to be stressful. I don't want this to be something that's keeping you up at night or you're doing all crazy. Like, you don't need to worry about that too much. I want you guys to have fun, but we'll put a little science in it. So this is some advanced science. Actually, we're going to do a little physics. And this is something that's pretty real world. The idea of how to keep things from breaking when they have massive amounts of force pushed on them. This is something that engineers do in the car industry, the auto industry. It's something that has been happening since the beginning of time. We've been creating parachutes and planes and all those things. How do you keep things from dying when they suddenly stop? Specifically with a fall. So we're going to learn that today. So we're going to be dropping eggs or water balloons, whatever works best for your home, off something high, whatever you'd like. It could be a ladder. It could be just holding it up. It could be the roof of your house, whatever is safe and whatever is agreed upon by your parents. So I am not telling you to climb onto your roof. Your parents do not want you to. I am telling you that you need to be contacting and talking with your parents about what you can do here. No, I just be sitting on a chair, dropping it. Your contraption. But we're going to be calculating some things. We're going to be working through some physics to see what happens with this scenario. So some things you might need. You will probably need a tape measure so you can measure distance, and you will probably need some kind of a stopwatch over you counting 1, 1,000, 2, 1,000. I usually just use my phone, an iPad. Your computer has one. You can use the internet, just say digital stopwatch, and it'll come up even on Google, and you can use that. So whatever you guys want to use that works. Let's get moving. This is your egg/water balloon drop. The goal is to understand how force works on an object, basically that big fall that's speeding up an object, that sudden stop. How can that help us create a contraption that'll keep it from breaking? We want it to survive. We're gonna watch some videos. I want you to start designing your egg drop contraption or water balloon. It could be a full design. It could be just a piece of a design. Whatever materials that you think you might need to do this. And then it can be any household materials you have, whatever you'd like to do. My only rule is that you can't put something like between, like, it can't fall on anything other than the ground. So you can't like put a mattress on you, like beneath it, and then drop it. That doesn't work. You have to build something around the egg, not just put something under it. Or water balloon. All right. Main learning. So I want you guys to understand force. I want you to understand speed, velocity, and acceleration, because those are big things. So velocity, such speed. So velocity is like speed. They're very similar, but they're different. Speed is is the speed of an object regardless of direction. So if you are in a car, you're calculating speed because cars take turns all over the place, and it's always going at that 35 miles an hour while taking turns through Parker. That is speed. Velocity is that speed in a direction. So as soon as the direction changes, the velocity has changed. So if you are traveling this direction at 32 miles per hour, and then you turn, this is a brand new velocity, whereas with speed, it'd be constant. You don't really need to know that. When I say velocity, it's the same. For our purposes, just think of it like speed, but they are different things. And then I want you guys to be thinking, like, how can this data be useful for you to help you design a new contraption? So if you want to do it twice, a couple times, and figure out what is going wrong and why, that's something to think about. So here are some of those videos. So it's trying to create some lift as the blades spin. Ooh, they got lucky. Here's some other ones.
This is the University of Rochester.
Very cool. You can see some of these designs are trying to suspend the egg. Scale because
you want to weigh your vehicle? Just to keep it upright, really. It doesn't slow down. The stock, nice little hammock on the inside. And hopefully it should take the impact well enough.
I worked on it for 4 hours this morning. I had a couple different designs though, and they weren't working out. And then I finally got to this design.
It's easily removed. I mean, I don't count it breaking, but it's a little heavier than everyone else's. So we'll see.
I'm hoping it'll be all right. It doesn't fall out. I dropped it off. I've got a couple stories from like the thing that goes in between. I just dropped it off without the parachute. It's fine in the box without a parachute. First team will be Splash.
Use the parachute technique. See, the big thing is the parachute is your presence.
This is the University of Rochester.
Want to get an egg cracking on the ground? This speed. Yeah. All right.
All right. So this is how you calculate velocity. Speed of an object in a direction. So it usually it has to have a direction with it. That's how velocity is counted. So it's like you see the bass boat was moving 12 miles per hour toward the north, like in that direction. If it was moving south, then it would go to 0. So that's the way velocity works. It's distance over time divided by time. So if I was looking at it and I had and that boat was going 15 meters. We do everything in meters. So if you need to think about it, it's your centimeters divided by 10 is your meters. So if you were going 190 centimeters, when you divide that by 10, you get 19 meters. Makes it super easy. I'm sorry. Completely scratch what I just said. I'm not even going to edit it out of the video. It's divided by 100. So if you have 190 centimeters, it'd be divided by 100. It's divided by 100, 190 over 100, which means it is 1.9 meters. So as we're going through and you're looking at your you're looking at this. So if I'm looking at distance over time, if I'm looking at 1,900 centimeters, which is actually 19 meters, right? And I'm dividing it, maybe it took 10 seconds to get there. I'm doing 19 meters, 19 divided by 10. So I have 19 is in the box divided by 10. It can go in once, and that is 1.9 meters per second. And we'll do another guess on that in a second. Acceleration then is the change of velocity divided by time again, which means that the unit for acceleration is meters per second squared. So acceleration is how fast something accelerates. So it's change. So think about it with a car. When they talk about cars going from 0 to 60 in 4.5 seconds, they're talking about acceleration. How fast can that car get from 0 miles an hour all the way up to 60? It has to hit all the other speeds in between at a certain point. Your egg or water balloon is going to do the same thing. It's going to start at 0. So this is actually really easy because your final velocity minus your initial velocity, well, your initial velocity is 0, isn't it? So if you're looking at it, if our final velocity is 6 meters per second minus 0, it's just 6 meters per second, again, divided by the time. You're just going to divide it by the time a second time. And what that's going to do is going to create how fast, like what was the acceleration of that object? How, when it went from 0 all the way to the ground, how fast was it reaching that? And that's your measure of acceleration. Now, acceleration is important because acceleration with a sudden deceleration, that's what causes damage, right? They always joke that when you're parachuting, it's not the fall that kills you, it's the sudden stop at the end. Same thing here. It's not the acceleration, but as you're speeding through the air, you're creating more and more force when you're going to hit that ground, or when that water balloon or egg is going to hit the ground. So it's your final velocity minus your initial velocity. So your final, when the very last velocity that's achieved, the highest speed that it reaches, minus your starting velocity. For this case, it's going to be 0. And then divided by the time again. Force is bonus because force is going to require a scale. Some of you may not have a scale, so I'm not going to require you to do this. If you do have a scale, weigh your object, because then you can see how much force is being exerted on that egg as it hit egg or water balloon as it hits the ground. And the unit of force is in a Newton, which is 1 kilogram. How much required to accelerate an object with a mass of 1 kilogram, 1 meter per second, or decelerate, bring it to 0, because when it really comes down to it, it's going to be 0. So your force is going to be your mass times the acceleration, and that's labeled in a Newton or N. For Sir Isaac Newton, who came up with the ideas of force, the laws of force. So let's practice. Okay, I want you guys to do this with me. So grab your pen and paper, pause, I'll wait. Perfect. And there is a typo on this, and I apologize for that. You time your contraption, right, as it's dropped off the roof of your house at 19 meters, which actually should be 1,900 centimeters, not 190. So not 190, 1,900 centimeters. And you get 2.4 seconds. What is the velocity? So you don't have to go off the roof of your house. This is just an example. You could just do it from a ladder. You could stand on a chair. It doesn't matter. You just need to know the height from which you are dropping your contraption. So let me say that again so everybody can hear it, so that even when parents are asking, why are you climbing up on the roof? Mr. Burley tell you need to climb up on the roof? No, I'm not telling you need to climb up on the roof. What I am telling you is drop your contraption from a high place, whether it's standing on a chair, whether it's standing on a table, whether it's being up on a ladder. The higher you go, the harder it is. Roofs are fun, but if that is not safe, please do not do that. And please not do it without your parents' permission. So get your parents' permission. Let the record show that Mr. Burley told you to get your parents' permission. So what is the velocity? So let's look at this. So I'm dividing. What am I dividing here? If we go back in my slide. Get velocity. The distance, I'm dividing it by the time. So I'm doing 19 meters divided by 2.4 seconds. Where is it? So 19 is in the box, 2.4 seconds is on the outside, right? So I'm going to move over that decimal because I don't want to deal with it. And I shifted it. And so my new equation is 190 divided by 24, right? Because I shifted that decimal place. And so then I'm going to go through. 24 goes into 190. Let's see, what's 5 times 24? That equals 20, carry the 2, 120. I can do more. Then I have times 20 plus 24 is 148. Plus 24 is 172. Can I do it again? I can't. So I have 5, 6, 7. 24 goes into 197 times. That's 172. So 190 minus 172. You guys see what I did? So I multiplied by 5 just because it was easy. And I just added 24s, and those are my new multiplications. So when I added another 24, that was times 6. Another 24 was times 7. If I did another 24, it'd be times 8, and so on, right? Never more than 9. And so then I subtracted, and I got 22. I added my decimal points. Do you see how I did that? So I brought that decimal point up. And I'm going to add a 0. And I'm going to bring down a 0. Now I'm at 220. I'm going to keep going with my division. We all know how to divide decimals. And if you don't, come see me at office hours at 2 to 3:30 each day, and I can help you through your division. So I have 220. I'm going to guess it's probably 9 there. So 9 times 24, 9 times 4 is 32. Carry the 3. 9 times 2 is 18, plus 3 is 21. So that's 220 minus 212 is 8. I'm going to do another 0, bring it down. I have 80 there. 24 goes into 80 three times. 3 times 4 is 2. Carry the 1. 3 times 2 is 6, plus 1 is 72. And that is 8. And then I have a repeat. It's going to keep going over and over and over. So my final velocity is 7.93 meters per second down. You see how I wrote that? 9.3 meters, 7.93 meters per second, m/s down. I need to make sure I have that direction. So now we do the acceleration. So let's go back. Well, acceleration is your final velocity minus your initial velocity divided by time again. And it's going to be meters per second squared. That's important because if you don't put the square, then it looks like another velocity. It's not a velocity. It's an acceleration. It's how fast is it reaching that velocity. All right. So let's look at that. So if I'm starting off, so I would do my final velocity that we just calculated was 7.93 meters per second, right? I need to subtract that from the initial velocity. What did my egg start at? Or water balloon. So with this, it's an egg, right? So I'm looking at my egg, and I'm saying, well, if it ended at 7.93, am I holding it here and I drop it? What did it start at? How fast was it going? It wasn't going fast anywhere. It wasn't going anywhere. So it's minus 0. meters per second. That's the nice part about dropping an egg. So what's 7.93 minus 0? You got it, 7.93. And I'm dividing it again by 2.4 seconds. And so we're going to go through that calculation again. Now I'm going to shift that decimal place because I don't want to divide by a divided by a decimal. I want to divide by a whole number. So I want to make it 24. So I'm going to shift it over times 10. So my new problem is 24, and it's 79.3 divided by 24. That makes it easy. And I can bring up that decimal right away. How many times does 24 go into 79? I already know that it's going to be 3 times. I'm going to start with 3. So 3 times 24 is 72. Subtract 9 minus 2 is 7. Bring down the 3. And then I'm going to say 3 again because I already know 3 times 24 is 72. I've been doing this a lot now. So I'm going to say 3 again. 3 times 24 is 72. I'm going to subtract. And that is 1. Bring down to 0 because there's nothing after. So I added a new 0 because there's an infinite number of zeros. And that's 10. How many times can 24 go into 10? 0 times. So I'm going to put a 0 up here after the 3. And I'm going to bring down, I don't need to do the math. I know it's 0, 10 minus 0 is 0. So I'm going to add another 0 to the end of that. I'm going to bring it down to 100. How many times can 24 go into 100? I'm going to say if it goes 3 times 24 to 72, if I add 24 to 72, I'd get 96. So I'm going to say 4. And that's 96. And that's 4. 100 minus 96 is 4. And I could go on, but I'm going to stop at the thousands. So it's, my final answer is 3.304 meters per second squared with the little superscript 2 up there. So I just calculated our acceleration. Now I can calculate my force, right? Because force is mass times the acceleration. So if I'm looking at this, if my egg is 56 grams or 0.056 grams, and your machine is 100 grams or 0.1 kilograms, what is the force of your contraption generated when it landed? Okay, so I'm looking at this. So I have 0.1 kilograms. I need to add it to my egg. So that's plus 0.056. So that's 0.1. I like to add a 0 sometimes just to keep it all lined up. 0.100 plus point, because when I'm adding decimals, I need to line up the decimal points. 0.056, which equals, that's easy math, 0.156 kilograms. Yay. I need to multiply that times my acceleration. So I'm going to look back. My acceleration was 3.304. I'm going to multiply it by 0.156. I'm going to go through the multiplication. And I'm going to go through that with you now. So if you know how to do this really, really well, you can skip. With any of this math, you could. But if you don't, I'd go ahead and sit and pay attention. I'm just going to start with what looks like the ones. I'm going to ignore the decimal, right? For right now, I'm just going to do 6 times 4, 6 times 0, 6 times 3, 6 times 3, and I'm going to keep adding my magic zeros. So 6 times 4 is 24, carry the 2. 6 times 0 is 0, plus 2 is 2. 6 times 3 is 18, carry the 1. 6 times 3 is 18, plus 1 is 19. So that's my first one. Then I add my place value 0 before moving on to the 5. 5 times 4 is 20, carry the 2. 5 times 0, 0 plus 2 is 2. 5 times 3 is 15. Carry the 1 again. 5 times 3 is 15 plus 1 is 16. And that would be my second one. So if you're doing this with me, that's what they look like. And then not one place value before I go to the 1, but 2 place value zeros. So I'm going to go 1, 2. So on the second line, I put that place value 0, underlined it. On these next 2 lines, I put 2 place value zeros because I'm moving 2 place values. And then the ones are easy because then I can just write the number backwards. So I just put a 4, 0, 3, 3. I'm going to add all those up. So 4 plus 2 zeros is 4. 2 plus 2 zeros is 2. 8 plus 2 is 10. Plus 4 is 14. I'm going to carry the 1. This is nice too. 9 plus 1 is 10. Plus 5 is 15. Carry that 1 again. So here's where I am. So I like to kind of add in tens. So if I have 1 plus 3 is 4, plus 6 is 10, plus 1 is 11. How you do this is going to be 11. Carry the 1. 1 plus 1 is 2, plus 3 is 5. And so I ended with all of my math ended up. The first line of multiplication is 19824. The second line of multiplication would say that we multiplied from the 5 is 165200. And the third line of multiplication that we multiplied from the 1 is 330400. When we add it all up, we have 515,424. But we're not done because we have decimal points. This is like the most of us have ever done. I have 6. I have 1, 2, 3, 4, 5, 6 numbers to the right of that decimal point. So I'm going to move it starting behind the 4. I'm going to move it 6 times. 1, 2, 3, 4, 5, 6. Takes us to the very end of our number. So our any newtons is 0.51524 newtons. Wow. That's a weird decimal. It's a big decimal, but that's what we've got. A lot of times as scientists, we'd probably round that to the nearest thousandth or whatever is most accurate, which would usually be like 515 thousandths newtons. But that's what we've got here. So here's what I want you guys to do. How can you use your understanding of force create a contraction that will keep an egg/water balloon from breaking when it is dropped? And you'll see in our in the lab sheet that I give you, it's going to go through those calculations. It's going to have you start making those calculations, but there's 2 things you can make changes to your water balloon if need be, or changes to your contraption if need be. So you're going to create something. You can put an egg/water balloon in that will keep it from breaking when it is dropped. You're going to do it outside. Don't do it inside. Try to find the highest point that is possible while staying safe. Talk to your parents about how that might help. Calculate the force of your egg/water balloons that it hits the ground with, and see if you can make adjustments to lessen that force. Post a video of your contraption, you dropping your egg/water balloon and the egg/water balloon after. And have fun. Don't ruin your house or apartment. Be sure to rinse the egg off any surface if you use an egg. Rinse it off all the surfaces because it'll stain if it dries. All right, everybody. I can't wait to see what you come up with. Post your videos, send them to me. We'll send them, and then we'll just have fun with it. I don't want this to be stressful. This should be fun. So enjoy it and have a good time. I will see you all later. Remember, I have office hours every day this week from 2 to 3:30. So if you need help with the math, please log on. Please do not message me at 6 and say, I didn't get the math. Just log on. If those hours don't work for you, message me with hours that do, and I will be sure to make sure to have them. I'll be sure to make sure to accommodate, and we can figure out another time. Okay. It's really weird that this is the last time I'm going to be signing off with you all. This is the way we're kind of ending school. I am so sorry that's the way it is. It was never our intention. And this is something that you'll remember for the rest of your life. And it's been a pleasure and it's been a privilege to be able to teach you and work with you all year. And I'll always remember it. All right, everybody. I will see you all later. Have a wonderful rest of your day.